Hello, this is Mr. Rasmussen with Algebra 1, Lesson 87. This one has two parts to the lesson. The first one here is just a step in a little bit further of a complicated equation. And then the second one is really simple, a test for a function. Let's look at the first example given in the lesson and work through that problem. We're given the equation r times t with subscript e's is equal to r subscript w times t subscript w. These stand for rate and time. We eventually get to some distance problems. So we're going to fill in the easy stuff first. It tells me that the rate of e is 200, so I'll write that in below there. It tells me the rate of w, or the r of w, is equal to 250, so I'll write that in right there. And then I don't have a value for t of e or t of w, but I have an equation that relates them. Now, what I want to do is take this and get one of them by itself, and then I can substitute the other parts in. So I'm going to subtract tw from both sides, and that gives me a new equation of te equals 9 minus tw. Then, now that te is by itself and I got t over here, I can substitute this in for that. So instead of writing te, I'm going to put parentheses 9 minus tw. And then, since tw is the only variable left in my equation, I'm just going to bring that down and I can solve for one variable. So let's solve this equation here. Remove my parentheses. I have 9 times 200, which is 1800, minus 9, not 9, minus 200 tw is equal to 250 tw. All right, then to get my tw term only on one side, I'm going to add 200 to both sides. And that gives me 1800 equals 450 tw. Then I want to get my tw by itself, so I'm going to divide by 450 to cancel here, and divide by 450 on that side as well. And that goes in 4 times. So my value for tw is 4. And then if I plug that back in over here, 9 minus 4, my te is equal to 5. Okay, and that is how you would simply plug the values in and solve that equation for the ones that are missing, in this case the te and the tw. Okay, the second part of the lesson here gives us some graphs. And I just briefly sketched these out here. And it asks us whether it's a function or not. And we've got a really easy thing to do. It's called the vertical line test. If at any point you can draw a vertical line, okay, vertical line up and down through the graph, and it crosses through 2 points, it is not a function. So if we look at this first example here, they're illustrating that you can put vertical lines through this and they only cross one time. So this one is a function. However, in this graph over here that actually graphs a circle, if you draw a vertical line through there, it crosses at 2 points. This is not a function. On the next page, if you flip over to 364, you got a couple at the top there. First one, if you draw a line through there, no, not a function because it can cross more than 1 point. The second one, yes, is a function, only one time, no matter where you put your line. Second one is no, it has 2 points at which a vertical line can go through there. Okay, so that is the vertical line test. All right, feel free to pause the video and work through the practice problems. I'm going to work through them now, and you can check your work with mine to see if you've got these two concepts here. All right, practice problem A. We have R1 T1 is equal to R2 T2. All right, what else do they give us here? All right, they give us the R1 is equal to 3, the R2 is equal to 6, and then they tell me the T1 plus the T2 is equal to 60. So we got to work with that one a little bit. Let's subtract the second one, as you do it that way. So T1 is equal to 60 minus T2, and substitute that in. So I'll put that in there as 60 minus T2 in parentheses equals 6T. Now you could do it the other way too. You could also say T2 equals 60 minus T1 if you were to subtract the first part. In that case, this part here would just be substituted in next to the 6 instead of the other way around. It would just give you the answer for T1, whereas right now we're solving the answer for T2 first. Okay, remove my parentheses. 3 times 60 is 180 minus 30 T2 equals 6T. Let's get my terms with T in there on the same side, so plus 30 to both sides. Looks like I get 36T equals 180. So I'm going to divide by 36, and 180 divided by 36 is 5. So T2 for practice problem A. Oh, that is not correct. Hold on here. I'm seeing a different answer in my answer key, so I gotta come back and see if I found a mistake. 60 minus T2. Plug that in. 180. Oh, yes. There's my mistake. 3 times T is not 30, it's 3. Okay, let's back up a little bit here. Okay, add 3 to both sides, add 3 to 6, we get 9T. There we go. All right, not 30, 9T. And if we divide both sides by 9, that gets us our correct answer, which is 20. There we go. Okay, so if T2 is 20, and I plug that in there, 60 minus 20, yep, right here, T1, looking at the wrong equation, and plug that in right here, 60 minus 20, then my T1 is equal to 40. Okay, let's work through practice problem B. On practice problem B, we have RO and TO is equal to RS and TS. And, oh, plus 16. They're changing it up a little bit for us there. Okay. My TO is 8, so let's plug that in. My TS is 4, so plug that in. And then I have RO plus RS is equal to -1. All right, once again, I got to get one of these two by itself so I can substitute it in. So let's subtract an RS from both sides. Cancels here. And my RO is equal to -1 minus RS. So let's plug that in. That comes over here. -1 minus RS times 8 is equal to RS times 4 plus 16. Okay, now that my equation's set up, let's work through that. 8 times -1 is -8. Once again, understood -1 there, -8 RS is equal to, I'm going to rewrite this a little bit, 4 RS and plus 16. And the same thing, just the order is switched. Okay, how about, let's add 8 to both sides here to combine my RS term. So it looks like I got 12 RS here. let's get this onto the other side. So subtract 16 from both sides. So I get a negative 24. Divide by 12 to get that by itself. Divide by 12. It looks like, 12 goes in there 2 times. So my RS value, is equal to negative 2. Come back over here. If I plug in a negative 2 there, that's negative 1, and then 2 negatives plus 2, so negative 1 plus 2 looks like my RO is equal to a positive 1. And that is the answer to practice problem B. Okay, as we look at practice problem C, it is a line that looks kind of like this. No matter where you put your vertical line, it doesn't cross 2 places, so yes, this is a function. For D, it looks like we have a line that goes like this. You can find a spot in there, vertical line test. It crosses 2 places. No, this is not a function. And then for E looks like this. You can put your line in there anywhere you'd like. It only crosses 1 time. And so E is yes, it is a function. Okay, once again, if you have any trouble and need further help, please feel free to contact me. Have a great day.